The graph to the right is a uniform probability density function for a friend who is X minutes late. Find the probability that the friend is between 20 and 25 minutes late. So you look at the horizontal line as a number line. So you want between 20 and 25 minutes late. So what you would do is on the top, you would have the distance between 20 and 25, which would be 25 minus 20. And you will divide it by the total horizontal distance that you see on this number line, which is from 0 to 30. So that's 30 minus 0. And so that gives you 5 over 30. That's 1 over 6. That's 0.167. There's a 20% probability the friend will arrive within how many minutes? So the total interval is 30 minutes and you just take 20% of 30. So 20% of 30. And that would give you 6 minutes. The graph to the right is uniform density for a friend who's X minutes late. Find the probability that the friend is at least 8 minutes late. Now, at least 8 means, 8 would be somewhere here. At least 8 means 8 or more. So you would see the difference between 8 and the final end. So final end is 30. So you would do 30 minus 8. Because 8 or more, you're going from 8 towards 30. So you would do 30 minus 8 on the top. And you will again divide by the total interval length, which is 30 minus 0. Okay, so you can calculate it. So that's 22 by 30. So that's 0.733. High temperatures in a certain city for August follow uniform distribution over the interval 67 to 87. So now the total interval is 67 to 87. What's the probability that a randomly selected August day has temperature that would exceed 72? So it doesn't matter whether you say exceed 72 or whether you say greater than or equal to 72 in case of a continuous variable. Remember, temperature is a measurement, so that's a continuous variable. So in a continuous variable, exceeding 72 and greater than or equal to 72 is same for the practical purposes. So exceeding 72. So now you can draw a number line in these problems. So let's do that. So the total interval is 67 to 87. So you would do 67 to 87 is the total. And they were asking that what's the probability that you exceed 72 Fahrenheit? So 72 would be somewhere here. Exceeding 72 means you're going this way. So the top, so this part which exceeds 72 is 87 minus 72. And the denominator is the whole total, which is 87 minus 67, whole difference. 87 minus 67. So that would be 15 divided by 20, so that's 0.75. Okay, so 0.75. So we once again have uniform. Identify the graph of the uniform density function. So they say the random number generator generates a number between 0 and 1. So it would generate a number between 0 and 1. So you are looking 0 and 1, 0 to 1 on the horizontal. So it's either graph B or C. So now in a continuous variable, the area under the probability curve has to be 1. So now in graph B, the height is 0.8 and the width is 1, so the area is 0.8. So that's not correct. But in this graph, the height is 1 and the width is also 1, so the area will be 1 times 1. So remember, it's a rectangle or a square. So this is the one that has area 1, and that has the correct numbers on the horizontal. It has to be between 0 and 1. So that's why it's this. Okay, the probability of getting a number between 0.86 and 0.98. So you do 0.98 minus 0.86 on the top. 0.98 minus 0.86 on the top. And you divide it by the total interval length, which is between 0 and 1. So that's 1 minus 0. And so that equals 0.12. And then you want a number greater than 0.95. So greater than 0.95. So again, you can do this on the number line as well. So greater than 0.95 is what we are looking at. So our interval is 0 to 1. And we are 0.95, let's say, is here. We are looking at greater than 0.95. So that'd be somewhere this region. So that region is 1 minus 0.95 and the total is 1 minus 0, the full line, and so that's 0.05. And once again, it's continuous variable. So don't think that greater than 0.95 means that you start from 0.96, because 0.96 is not the next number after 0.95. After 0.95, you even have 0.9501, and you can even have a number between those two. So it's a continuous situation. So it once again does not matter whether they said greater than 0.95 or greater than equal to 0.95. You just start from 0.95. So the answer was 0.05 as we calculated.